Now let's look at another series of integrals. Any questions so far about anything we've done? I should pause for questions. Any questions? Janelle, what are your questions? Janelle, what do you got? No questions? Okay. Okay, so look at all three of these integrals. They are very similar, obviously. So I'm going to give you a few minutes to work on these. Let's say 4 minutes. And I'll also scroll back up a little bit in case you didn't get to copy the other parts. F is that absolute power thing, right? I don't know, something with ln maybe? Okay. So let's get these out of the way. So Caleb, since you asked about it, what's the antiderivative here? So how would we compute this?
I put just ln to the x.
Just ln
Is
to the x? What does that mean, ln to the x?
ln x.
ln of x. Okay,
Yeah.
good,
And then it's
right?
positive because
Because the derivative,
everything's
right, you don't need the absolute value bars. Very good.
Yeah.
You can put them, but they're kind of redundant, right? Is the derivative of ln of x 1 over x? Yes. And are we on the correct interval? X is all positive, so I don't need the antiderivative, the opposite value. So I plug in 1 and 2, I get ln 2 minus ln 1. ln of 1 we know is 0, so I get ln 2. Okay. Nice and straightforward, nice and easy, right? Okay, so now let's start making things slightly more complicated. So what did you get here? What is my antiderivative for this function? ln of x plus 1. Okay, good. Right, you can always double check it. What is the derivative of this? It's 1 over x plus 1, and that's times 1 by the chain rule. So I do get back the original function. Okay, so then I plug in the two numbers, 0 and 2, and I end up with ln 3 minus ln 1. So I end up with ln 3 as my answer. Okay, and now the last one. So what did we get for an antiderivative for this function now? Uh-oh. Justin, did you get one? Or, oh, it looks like Margaret got one. ln of 2x plus exclamation point over 2. So you're all writing this 1/2. Okay, good. So we get 1/2. All of you in chat are writing this extra factor of 1/2. So that's correct. So first of all, let's see why that is correct. Right, if I were to take the derivative of this, let's do a quick check. What is the derivative? Now, when you first, I don't know how you actually work this out. You may have actually just guessed that the 1/2 is there, but I imagine some of you actually may have thought that the antiderivative was ln of 2x plus 1 without the 1/2, right? Or you may have guessed that first and realized it was wrong. So let's actually look at that first. Why is it not just ln of 2x plus 1? Why was this 1/2 needed? Well, if I were to take the derivative of ln of 2x plus 1, what do I get? I get 1 over 2x plus 1 and then times 2 by the chain rule. And notice that that 2 is not in the original function, that extra factor of 2. So I am off by a factor of 2 with my antiderivative. Now, the nice thing is that we know if you are off by a coefficient, remember, coefficients come in and out of derivatives, they come in and out of integrals. Coefficients really don't matter. I can always correct for the coefficient later because coefficients just kind of come along for the ride. So if you're only off by a coefficient in your antiderivative, what you can do is you can correct for it by adding another coefficient. So in this case, because I get an extra factor of 2 when I take the derivative of ln of 2x plus 1, if I want the correct antiderivative, let's put this in red so it's very clear that this is wrong. Now what happens if I have that extra factor of 1/2 to correct myself? Well, the 1/2 comes along for the ride as a coefficient, and then I get the derivative of the ln function, which is 1 over 2x plus 1 times 2 by the chain rule. And those 2's cancel out and give me back the original function. So that is very clearly the correct answer. Right. So if your antiderivative turns out, if you guess an antiderivative and it turns out to be wrong by a constant factor, you can always correct for that. If it's wrong by something else, like for instance, if I'd actually found out, oh, my derivative is 1 over 2x plus 1 times 2x, I'm off by 2x, that's no good. If you're off by a non-constant factor, you cannot easily correct that. Because we know that, for instance, if you thought, oh, I'll just divide by 1 over 2x, right? I'll just divide by that to correct for it. That's no good, because 1 over 2x, we know that when you take the derivative of the next thing, it's not going to come along like a coefficient, right? So you can only do this trick of dividing by the coefficient if you're only off by a constant coefficient. Okay. Now let's just actually finish everything up here. So the 0 again gives us ln of 1, which is nothing. So I get 1/2 ln 5 for the final answer. But the big thing here is to understand how you deal with constant coefficients. So let's look at another